This is Algebra 2, spring test number 5. We omitted a few problems from the test, but we do have number 1 and 2 on there. We're multiplying and simplifying if possible. You can only multiply radicals like this, like the cube root of 5, the fourth root of 5 times the fourth root of negative 5, if the bottom number is going to be the same. What we're going to get when we try to put these two together is the fourth root of negative 25. And there is no real number that does that. That's the reason it's not possible. Now, in here, we have gone through and we've fooled with the imaginary numbers, but we won't be able to work them into the imaginary numbers with this one. Now, had this been something like the cube root of negative 8, we would have been okay, because you can do a negative 2 times a negative 2 times a negative 2 to simplify it. But since it's the fourth root, since it's an even number, and we talked about evens versus odds over the last couple of days, that's the reason it's not possible. So just write not possible when you see something like that. And number 2 is much, much simpler, especially since it's dealing with square roots, and most of us feel okay with square roots. There's 2 different ways to do it. You can take out the common factor, which is the square root of 6, and separate this into the square root of 6 times the square root of 3. Because when this multiplies times the square root of 6, then you know you have the same radical multiplying by itself, which you just take the 6 out times the square root of 3. Most of y'all probably didn't do it that way, though. That's the fast way to do it. Most of y'all probably broke it down into the square root of 9 times the square root of 2, and then 3 times the square root of 2 times the square root of 6 would have given you the square root of 12, and you'd have broke that one down as well. This is just a faster way to do it. Make them the same. And anytime you multiply the same radical by itself, you remove the radical sign. These are the 4 we're taking off. Okay, add these if possible. If all this one right here said was 5x plus 6x, everybody would be fine just saying that that was 11x. We're going to treat it the exact same way. We're going to treat that radical as if it were just a variable. But instead of being 5x plus 6x, now it's 5 times the square root of 3x plus 6 times the square root of 3x. So we're going to leave it as 11 times the square root of 3x. That's all we can do with that. The same thing's true with the next one. Notice it's the cube root of 2a. That's the same for both of them, the cube root of 2a. So that's like the same type of term. You can subtract 2 minus 5 and get negative 3 times the cube root of 2a. And that's just doing 2 minus 5. Okay, you can do these 2 different ways. You can write them in radical form, because you know that 2 is the index, so you'd just be taking the square root of 9 and raising it to the first power. Or you could say, well, they're multiplying the same basis, so I add the exponents 1/2 plus 1/2. You know that 1/2 plus 1/2 is 1 whole, so that's 9 to the first power, which is simply 9. Number 10 says 10 to the 1/3 times 100 to the 1/3. Okay, so 10 to the 1/3 times 100 to the 1/3. Who like this? It'll be close enough. Number 11 says 8 to the 2/3 power. Now, with this, you're going to have to write it in radical form. You know that this is your index. So that is the cube root of 8. And all of that is the numerator raised to the numerator squared. So the cube root means what times itself 3 times is 8. You know that that's the number 2, and 2 squared is 4. Okay. Calculators do stuff like that, but some of these aren't even necessary to use a calculator for. 9 to the negative 2.5 power. Now, the only thing that negatives tell you to do is ride the elevator. So when it goes down, it's going to become 1 over 9 to the positive 2.5. Now, we hadn't talked about decimal exponents. But decimals, everybody in here knows what 2.5 is. They know 2.5 is 2.5, which 2.5, if you make it into an improper fraction, will be 2 times 2, which is 4, plus 1, which is 5. This is the same thing as 5 over 2, so 5 halves. So it's really a much easier problem than it looks. So what it turns into is 1 over 9 to the 5 over 2. You know that the bottom number again is the index, so it's going to be the square root of 9. You can write the 2 there if you have to. But all of that's going to be raised to the 5th power. So you know the square root of 9 is 3, so it's 1 over 3 to the 5th power. And 3 times itself 5 times is 243. So 1 over 243. Again, really the only even remotely tough part is the fact that it was in a decimal form instead of being in a fraction form. 2.5 is the same thing as 5 halves. Write this one in radical form. So it's 5 times x to the 5 over 3rd power. This is not being raised to the 5 over 3rd power. So what it looks like is 5 times, this is your index, cube root of x to the 5th power, like this. The 5 is not being raised. Same thing like as if you had 2x to the negative 1. You would not ride the elevator with 2 in that case, just with x. Only the thing that's right next to it is being raised to the exponent. 14 says to write this one in simplest form. You're raising a power to a power now. Now 8 is being raised to the negative 2/3 power. You have to make sure to distribute it to the 8. So now you have 8 to the negative 2/3 and a to the negative 6 to the negative 2/3. This is when you multiply it. Anytime you raise a power to a power, you multiply it times negative 2/3. So multiplying that straight across, a negative times a negative, we know is going to be a positive. 6 times 2 is 12. Divided by 3 is going to be a to the 4th power. If you need to write that stuff out, you can. A to the 4th power. The other one says 8 to the negative 2/3. Remember, the only thing that the negative tells you to do is ride the elevator. A to the 4th power is not going to ride the elevator. It's going to stay at the top. So when it goes down, it was over 1. A to the 4th is going to stay on top. 8 to the 2/3, it's going to become to the positive 2/3. Then just write it in the index form where you can see it. So it's going to say a to the 4th over, the index is 3. So it's the cube root of 8 squared. The cube root of 8 is 2. And then 2 squared is 4. So a to the 4th power over 2 squared is 4. Most of the cube roots and 4th roots we'll work with will be very simple numbers like 2 and 3, because they start to get extremely difficult when you get larger than that. And then we're going back to stuff we were doing last week. D squared minus 7d plus 10. Separate these into 2 binomials. You're going to have d times d to get d squared. You need the factors of 10. 1 and 10, 2 and 5. 2 and 5 is the only ones that get you to 7. Same signs, both negative. Minus 2, minus 5. Over, do the same thing with the bottom. D times d gives you d squared. 14, you have to use 1 and 14 or 2 and 7. 2 and 7 is the only one that gets you to the number 9. So we're going to use 2 and 7. Same sign, both negative again. Cancel out what's exactly the same. D minus 2 is exactly the same as D minus 2. So you're left with D minus 5 over D minus 7. D to the 4th minus 4d squared minus 12. Unlike the last one, this one's going to be separated. Instead of d times d, it'll be d squared times d squared, and it'll be the same on the bottom because it's d to the 4th power. So then just do your factors of 12. 1 and 12, 2 and 6, 3 and 4. The only ones that get you to the number 4 are 2 and 6. Different signs, bigger one's negative. Negative 6 plus 2. 48 has a lot of factors, 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Which pair gets you to the number 14? 6 and 8 are the only ones that are going to get us there. 6 and 8. Same sign, both negative. Minus 6, minus 8. What's exactly the same at the top and the bottom? The D minus 6 part is exactly the same. D minus 6. D squared minus 6. So D squared plus 2 over D squared minus 8. $17, multiply, divide, state any restrictions. Okay, there's nothing we could do with K minus 5 or K plus 4 yet. We can change our division into multiplication and multiply by the reciprocal. So when we separate that second fraction into two binomials, this is the bottom, is becoming the top. We're going to say K times K to get K squared. 1 and 8 and 2 and 4, we got to use 2 and 4. This one says they the same sign. This one says they both plus. So plus 2 plus 4 over K minus 4. Cancel out what's exactly the same. K plus 4. So you got K minus 5 on top times K plus 2 over K minus 4. The only restriction on the variable would be very simple in this case. If you see something, and it'll definitely show up like it always has been. What's going to make it 0 on the bottom? The only restriction you can have is it can't be, X cannot be, or K cannot be equal to positive 4. 4 is a restriction on the variable. Can't make 0 at the bottom. 18 factor, this is simple. Just do X times X to get X squared. 1 and 50, 2 and 25, and 5 and 10. 5 and 10 is going to be the one that's going to get you to the B value, 15. Same sign, both plus. Plus 5, plus 10. 19, solve the equation, check your solution, undo your order of operations. Remember, before you try to undo radicals and exponents, undo addition and subtraction. You go backwards through your order of operations, your Aunt Sally part, subtract 8. 9 minus 8 is going to be 1, is equal to the square root of n. You know how to undo the square root of something, you square it. If you square it there, square it here. 1 squared is still going to be 1. N's value is 1. Solve the equation by finding square roots. Again, before you try to undo squaring something, you have to undo the my dear part, the multiplication and division part. Divide by 5. Do it here. X squared equals 6. Get rid of x squared by taking the square root. Do it there, do it here. X is both the positive and negative square root of 6. Can't break that radical down any farther. Complete the square for this one. This is a bad C. It won't give us a perfect, it's not a perfect trinomial. So x squared plus 2x plus C equals, if we move it over, it's going to say negative 2 on the other side of the equal sign. We got to find our value of C. C is going to be B divided by 2 squared. B in this case is 2. Divided by 2 is 1, and 1 squared . 1 squared is positive 1. I made a mistake a minute ago. When I brought my negative 2 over, you need to add 2 to it. It's actually going to become positive 2 on the right. But if you add 1 to the left side, the new C value, you need to add 1 to the right side to balance it out. So now you have 3 on the right equals, here we have ourselves a perfect trinomial. Take the square root of the first one, and it's x. The square root of the last one, and it's 1. The sign in front of B goes between them. So it's x plus 1 squared is equal to 3. And now solve it just like the last couple of problems. Undo x plus 1 squared by taking the square root of it. If you do it there, do it here. That'll cancel this out. X plus 1 equals the square root of 3. And then get rid of plus 1 by subtracting it on both sides. So you have, if you write this in standard form, it'll say x is -1 plus or minus the square root of 3, just to represent both positive and negative. And then number 22 is rewrite the equation in vertex form. Vertex form is, it's x minus h squared plus k. Okay, x minus h squared plus k. Again, though, you treat it almost like the last problem we just did. This is a bad C value. So we're going to subtract 0. There's no reason to subtract 0 on the other side. It just goes away. So we have y minus 0 on the left equals x squared minus 6x plus c. We need a new c value. We're going to take our value of b, 6. It's -6, but when we divide it by 2, we're going to get 3. When we square that -3, it's going to come back to being positive. So it'll be plus 9 is our new c value. But if you add 9 to the right side, you got to make sure to add 9 to the left side. So put it in plus 9. Now take the square root of this one, since it's a perfect trinomial. Take the square root of this one, it's 3. This is the sign that goes in the middle of them. X minus 3 squared, it's a binomial squared, is equal to y plus 9. One more step to make it vertex form. We need to move over the plus 9 part by subtracting it. If you subtract it there, subtract it here. You can't subtract it from -3 because that's inside of the parentheses. So what you're left with is y equals x minus 3 squared minus 9. And this is vertex form. So if you were asked to identify the vertex, remember it's the opposite of what you see in parentheses for the x. So it'll be +3. And it's exactly what it says on the outside, -3.